Alright, so finally I've set up everything and all ready to roll. I'm Avik Dhupar and she gave a wonderful introduction of me. Thank you. So I'm going to be talking about how do you interface Arduino and Python, and how do you knit together something that relates to the Internet of Things. So before we move ahead, let's see what Arduino is. I'm pretty sure Sudhir and the speaker right before me has covered quite a lot about Arduino. In fact, this is the third talk in row about Arduino. So looking at what Arduino is an open source electronics prototyping platform which is based on flexible, easy to use hardware and software. So it is basically intended for artists, designers, hobbies, etc. and for anyone who's interested in creating interactive objects or environments. This has been taken from the Arduino website. So Arduinos are available in a lot of different flavors, and I have an Arduino Uno over here with me for the demo. Then we have multiple other Arduinos. We have Milano, we have Arduino Bluetooth, Mega, and quite a few other Arduinos. Another special Arduino that we have is the LilyPad that you see on the top left, the round one. So Arduino LilyPad is basically used to create wearable electronics or wearable computers or anything of that sort. Let's see why the Arduino revolution was there. Let's see why it actually all happened. What is so special about Arduino? So Arduino is very easy to use. You guys must have seen quite a lot of code so far and must have discovered that it's really easy to use. Something on the lines of Python. I mean the ease, definitely not the language. It is pretty cheap, and you can make one by yourself if you want to. It is intended actually for artists and designers and not really engineers like quite a few of us over here. Well, made in Italy, that's where it all started, and it is open hardware and open documents. The only thing that is closed with Arduino is the silk screen of the Arduino. So basically you can take the Arduino's firmware, you can take the microcontroller, you can develop your own boards, you can print your own boards, and that is why the Arduino is here to stay. So let me just quickly rush you through as to what is there on the Arduino board or in the hardware. The hardware is basically the device. It's an electronic prototyping board. The software that comes along is a bootloader. The bootloader is a small piece of software that runs on your Arduino board, that runs on the microcontroller on the Arduino board. It is something similar to an operating system, if I can call that. The software, Arduino comes along with a lot of loaded libraries. You have libraries to interface almost everything with Arduino. So you have libraries to interface ultrasonic sensors, simple IR sensors, sound sensors, a lot of different kind of sensors, and a lot of different kind of hardware actuators as well. Another piece of software that comes with the Arduino is the Arduino IDE, which is of course required to develop your Arduino code and to upload your Arduino code to the platform. The Arduino IDE also comes with something called as the serial monitor, and that is something that basically helps you to see the serial data that is coming in, or to send some serial data to the Arduino. The amazing part about the Arduino is the Arduino community. Arduino community is really vast. It's huge. So we have people spread around the entire globe, literally each and every country, who are using Arduinos and developing a lot of new things. So if you need any kind of help or support, head on to the forums, and I'm pretty sure you'll get it there. There's a lot of different manuals that are available with Arduino. So you have a manual or a tutorial or a lesson for learning almost everything as to how to accomplish it with an Arduino. Of course, there's a lot of examples that are bundled along with the Arduino IDE, and I'll quickly rush you through them very soon. So this is how an Arduino Uno looks like, and the Arduino basically comes with a lot of different pins on the microcontroller that are broken out for ease of use. So number one, we have the USB plug, which is used to, of course, interface the Arduino with your computer. Then we have something called as the analog reference pin on the top left, which is basically a reference for analog voltages. You have a ground over there. Then you have about 14 digital input-output pins. So these digital input-output pins allow you to send any kind of digital data over to the Arduino, or read or send any kind of digital data from the Arduino. Of course, along with the digital pins comes something called as PWM, or pulse width modulation, and this is in a way something very similar to writing analog values, or something very similar to a DAC. Two of the pins of the digital I/O also pair up as serial TX and serial RX, that is the transmission and reception line of the Arduino, and these are basically the pins that allow you to transfer data or send data over a serial connection, or RS-232 on a TTL level, and this is how basically the Arduino communicates with the computer as well. You must be wondering, I'm talking about serial over there, and I'm telling you that that's how the Arduino communicates with the computer, and we have a USB plug over here, so a kind of mismatch, right? Well, no, not really. The IC you see here on the top left, right next to the USB plug, is a USB to serial converter, and this is what allows you to convert the USB part into the RS-232 type of communication. And when you connect an Arduino to your computer, well, of course it is detected as an Arduino, but it also shows up as a serial port on your computer. There we have a reset button, which is once you press the reset button, of course the code does not go away, but well, the code restarts and it starts playing again from the beginning. Here we have the Atmega 328 microcontroller, which is the brain of the Arduino, and we have 6 analog input pins, and these are the pins that allow you to read analog values into the Arduino. So these pins can also pair up as digital I/O pins, and reading an analog value basically means that you can give any voltage between 0 to 5 volts. I say between 0 to 5 volts because Arduino operates at 5 volts. So if you give anything more than that, it's definitely going to fry your Arduino. So if you give any voltage between 0 to 5 volts on your analog input pins, that is going to show up as a particular voltage or a particular reading in the Arduino. Then we have an external power supply over here. You can connect anything between 7 to about 15 volts onto this, and you have the reset pin, which is basically similar to the reset button. Then you have a 3.3 volt power pin and a 5 volt power pin, and of course you have ground pins and the voltage input pin. The voltage input pin basically gives out the same voltage as is coming in from the external power supply. So talking a little bit more about the microcontroller here, it's basically an Atmega 328 on the Arduino Uno, and it has a RAM of 2 KB. That might sound a little too less relative to your computers. Well, to your computers it is definitely less, but for a microcontroller this is a decent amount of memory. It has 32 KB of ROM and a KB of EEPROM. As mentioned earlier, 14 digital pins and 6 pins that are capable of PWM, or pulse width modulation. You also have 6 analog inputs, and it can basically go up to 16, or actually it can go up to 20 megahertz, but on the Arduino it is being used at 16 megahertz. How do you interface the Arduino to your computer? Well, by now I'm pretty sure all of you must have gone through all of these things quite a few times, but I'll just quickly rush you through this. So an Arduino can be connected to your computer over a USB port, and it shows up as a serial device. And other ways of interfacing Arduino are using Bluetooth or using Ethernet. So there's a board that has a Bluetooth module on board, and it's called as the Arduino BT. So you can simply pair up and upload or send or receive data from your Arduino using Bluetooth. And The third way to interface is using Ethernet, and there's something called as the Arduino Ethernet, or an Ethernet shield that comes for the Arduino, and you can very well use that for interfacing to your computer as well. So how do you basically program the Arduino? Okay, it is as simple as setup, loop and blink. So you guys will discover what I'm talking about over here when I rush you through a small piece of code. Is the piece of code here visible there at the back? No? Alright. Okay, now, yep, that's great. Okay, so this is a very simple piece of code that runs on an Arduino board, and this code basically blinks an LED. What this means is that it is simply going to put on and then put off an LED. In the world of microcontrollers or embedded systems, a blinking LED is very much equivalent to a hello world example on your regular computer software. So the structure of an Arduino program is as such. You have a function which is called as setup, and you also have a function which is called a loop. So the setup function is basically executed only once in the beginning, and the loop function keeps executing after the execution of the setup function. In this case, inside the setup function, you are basically initializing the digital pin number 13 as an output. How do you do that? You just simply set it as pin mode, the pin number, and set it as output or input. If you set it as output, of course you can write values to it, but because it's a digital pin, you can only write high or low values to it. You can also set it as input, and in case you set it as input, you can read the different values that are coming in. Again, as I said, it's digital, so you can either read high values or low values. Looking at the loop function over here, inside the loop function, this basically keeps executing over and over again. Because if this does not happen, if you do not execute the same code over and over again, your controller is basically going to halt after you have executed your statements or your program. So assuming that the loop function does not loop, if you execute this piece of code, the light is only going to turn on, turn off, and then the microcontroller will halt, and in that case your program won't move further. So what is happening over here is we have already set pin number 13 as output, and we are doing a digital write on pin number 13, and we are writing the value high to it. High means we are writing 5 volts to it basically. What that is going to do is put the LED on. After that, I give a small delay of 1000 milliseconds. This is only there to let the LED be on. Otherwise, if I don't put the delay, the LED is going to blink way too fast for our eyes to observe. Because, well, the Arduino is executing at 16 megahertz, which is still quite a lot for our eyes to see or observe. After that, I do a digital write on pin number 13 and I write the value low. This is going to switch the LED off, and after that I give another delay of 1 second, and the same code keeps executing over and over again. I'm going to upload this piece of code onto the Arduino board and show you a small demo. I'm not very sure if you can see it there at the back, but you will see an amber colored blinking LED over here. Do you guys see it? That's great. So this was a simple blink example. Now moving on to interfacing Arduino with Python. Well, as I mentioned earlier, the Arduino shows up on the computer as a serial device or as a COM port. So Python makes accessing the Arduino very easy using something called as the PySerial library. You can download the PySerial library and simply access your Arduino using the same library. So this brings quite some opportunities to have a real interaction between the computer and the physical world. The computer, well, of course, it has all your software part running and it has all your websites, etc. running. And the physical world, you can interface the physical world with the Arduino. Alright, so, well, of course, Arduino talks and listens. So it is possible to send and receive messages to and from the Arduino, of course, with the right program that is uploaded on it. It is possible to talk over serial, RF, Ethernet, and, well, a lot of different other ways. Even Wi-Fi, and as I mentioned earlier, there are multiple ways to access or talk to your Arduino board. You can of course attach sensors and relay their readings onto your computer or onto another base station or wherever you want to. So you can have a temperature sensor placed in the room right now and you can read those values and send those values across over to the web or anywhere that you'd like. Along with that, of course, you can attach actuators and make things move. But hold on, in the case of actuators, I do not suggest that you connect your actuators straight away to the Arduino board. The reason I say this is because your Arduino board is basically a microcontroller board and it basically supports a lot less current flowing through it. So if you want to interface a motor along with your Arduino board, you need to use something called as an edge bridge or a motor driver. Because if you connect the motor directly to your Arduino, it's going to burn your Arduino because the motor draws a lot more current than your Arduino supports to sync or source. Making things work. So even if Python is installed on your computer, you still might need to get the PySerial module. And PySerial has a wonderful documentation which you can find on their SourceForge page. And if you are running Ubuntu, in that case you can simply download the Python serial package as such, your regular way. So we will need to upload a program on the Arduino board to solve our purpose. This is another simple example in which we have the setup function and the loop function. In the setup function, I am initializing my serial port so I can send or receive data over the serial port. In my loop function, I am just simply printing hello world and waiting for a second. Now when this particular program executes on your computer, on the Arduino, what happens is that the serial port is initialized, a serial connection is established between the Arduino and the computer, of course if you open it from the computer's end, and once it enters the loop, it keeps printing hello world onto the serial port and wait for a second before it prints it again. I have the same code written over here. Once I upload this program to the Arduino board, alright, it is done uploading. So as I mentioned earlier, there's something called as the serial monitor that comes along with your Arduino IDE, which allows you to see the data that is coming in or allows you to send data to the Arduino. So if I open the serial monitor in this case, it's going to print hello after 1 second. This is a very simple example of printing serial data onto the computer. Now at the Python end, all you need to do is these simple 2 lines of code. That's about it. You import the serial module, you create an object ser equal to serial.serial of the device name and the baud rate. Baud rate is basically the speed at which your Arduino is communicating with your computer. So as you've seen in the example, I had set the baud rate to be 9600 back in the Arduino example as well. So whenever you are communicating with your Arduino, whenever you are communicating between the Arduino and your computer, you need to ensure the baud rate is the same. 9600 baud rate is a very well used but a really old baud rate, and you can change this to any value that you like. After that, inside a while loop, you simply do serial.readline, and this is going to print hello or hello world. So this was the basics of Arduino and how basically you interface Python with Arduino. But I said Internet of Things. So what is basically the Internet of Things? A small part of Internet of Things consists of connecting your devices to the web. Almost each and every device of yours is connected to the web. So that is what I'm going to do now, and I'm going to show you an example of how you can basically make a small security sensor or a small security device which is going to send an email to you whenever it is touched. Okay, so this is a very simple example on your Arduino related to the Arduino, in which I'm using the CapSense or the capacitive sensor library. In this case, what I'm going to do is connect a simple piece of aluminum foil to the Arduino and try using this as a capacitive sensor. This is very similar to the capacitive sensors that are used in your mobile phones. So the wonderful thing about the Arduino community is that it has a lot of libraries. Again, in order to implement this piece of example, I really do not need to author a lot of code. I can simply make use of the capacitive sensor library that is available. Rushing you quickly through the code, I create an object of capacitive sensor type called cs_2_4, and 2 and 4 is basically the pins on which the Arduino's capacitive sensor is going to be connected to. So here on my Arduino board, between pins 2 and 4, I have put a 500 kilo ohm resistor, and to the pin number 4, I have connected the capacitive plate or the aluminum foil. The resistor in this case is required for the capacitive sensor to work. After that, I set the threshold above which my trigger should be executed, and then of course we have the seconds between emails. This is the amount of time within which I do not want another email to be sent. That is to say, if an email is sent after 1 minute, let it go, but if it is sent, if 2 emails are sent within a minute, let it not pass through. Last send is basically the time at which the previous email was sent. Looking at the setup function here, I simply initialize my serial port, again at the baud rate of 9600, and inside my loop, I declare a variable called as now, which basically gets the value of the number of milliseconds that have been elapsed since your Arduino started. So if it has been a total of 10,000 milliseconds since your Arduino started, or since you connected the power to your Arduino board, now is going to hold that value. Sensor1 or SENS1 in this case is a variable which is basically reading the capacitive sensor's value. So I created the object CS2 earlier, and I'm reading its value, and 30 is the number of averages that I want the capacitive sensor to do. After that, I am simply printing the sensor value onto the serial port, and after that I am just comparing if the value is greater than the threshold. If the value is greater than the threshold, I am going to print movement onto the serial monitor, and also I am going to send the last send time to now. If the value of now does not satisfy what I want, in that case it is going to go to the else, and it is going to print too soon, and it is not going to send the email. After that, I just do a simple delay of 50 milliseconds in order to allow the serial data to flow through. And once I upload this code to the Arduino, so this is the serial monitor, and it is currently printing the value that is read from the capacitive sensor. As soon as I touch this capacitive sensor, it printed movement. Again, in order to see movement, I'll have to wait for 60 seconds as I have programmed it on my code. If I don't wait, it is going to print too soon. Here it has printed too soon. And right here it has printed movement. So well, my Arduino side is working now. If I touch the capacitive sensor, it is going to send movement to your computer. And if again the time is too less, it is going to send too fast. Once I have this piece of code up and running on the Arduino, I can write a very simple Python script to read the data that is coming in. Okay, well, I'm really sorry. My computer has overheated and it turned off. Give me a second while I get it back up. Do we have any questions so far? No? Okay. Yep.
Hey, I know that the Arduino IDE or the Arduino hardware uses soft reset, right? So whenever you connect to serial port at a particular frequency, it tries to reset itself. Wouldn't that come into picture when you're trying to connect it from Python?
Well, yes, that's a wonderful question put forward by Sudhir. And the question is that Arduino uses something called as the software reset, or whenever you open a serial connection, as soon as your serial port is opened onto the Arduino, it's going to reset. That's what your question is?
Yes.
Alright. Well, that really wouldn't be an issue when you're connecting with the Python console or whatever you're doing with your Python, because what's going to happen is you are going to open the serial port and it is going to reset them. Once it resets, your serial port remains open. So if your serial port remains open, it is of course not going to reset. Yes?
So I have to, so every time I connect to Arduino will reset. So I cannot open a connection, close it, and then reconnect again, right?
Of course you can do that as well, but in that case,
yeah, so it will reset whenever I do that. Okay.
In order to avoid that kind of reset, you can basically disable the software reset. So to disable the software reset, there are two major ways. One is to cut out a jumper.
I'm aware of that. I'm just wanted to know whether that's correct or not.
Yeah, well, that's correct. And you can disable that using either a capacitor on the board or just cutting out the trace on the board.
Hi. Do you know any library for plotting the value from Arduino?
Sorry?
Do you know any libraries for plotting the value of Arduino?
For plotting the value?
Yes.
Okay, well, you want to graph the values that are coming in?
Yeah.
Well, yes, there are in fact quite a few softwares that are available, but of course you can do the same thing using Python very easily. Of course, you have libraries such as SciPy, NumPy, and Matplotlib, which allow you to easily graph, plot, and do all these things. So you can simply read in the data and use Matplotlib to plot whatever data is coming in. Also, there's an alternative to this on Windows, which is probably called as serial graph. So that's an application that you can use, and that is simply going to take your data as it is in a particular format, of course. You can set it to be CSV or something, and you can simply use that software, program it on the Arduino, run the software on your Windows machine, and it's going to plot all your values.
Any other questions? Hello.
Yeah.
So you said that this was designed for designers. So can you give some examples of how they are using it?
All right. Thank you for your question. How was Arduino designed for designers? Well, as you must have seen by now, that Arduino is pretty easy to use. Unlike any other hardcore C or assembly or anything of that sort, which is usually used for microcontroller programming, Arduino uses its own language or its own kind of script. So it is based on C, C++, and the reason I say it is made for designers is because it is so easy to use. Because it is so easy to use, designers can very well use it, right? And an example of this is interactive installations. So very recently, I came across someone from Coca-Cola, and they were working on something on a machine that ejects a Coke bottle or a Coke can when you hug it, right? So this is one example where Arduino can be used. You can very easily design something that will detect a hug using, of course, a capacitive sensor or any other method to detect human touch. Once you detect the human touch, you can have the machine eject your Coke bottle. So this is one example of interactive design or interactive advertisement. I'm pretty sure you're going to see quite a lot of this in the coming future in India, of course.
Hello. Do you have any code which can actually write or update when it is running?
I did not get your question, I'm sorry.
When you have one functionality built into the software and you want to change it on the go, so do you have any of that sort? Means you want to do a OAT or something of that sort. Means you want to update online.
Okay, you want to update the Arduino code online. Well, yes, there are a couple of different ways in which you can update the Arduino code over the air. The most commonly used way is using Bluetooth, if I can call that over the air. But otherwise, well, there are hardly any means to do it. Of course, you can have an interface on your computer which will relay all the data and which will upload the code for you. But as such, along with the Arduino, the original Arduino software or the hardware, there's nothing as such built in. The only closest thing that comes along with it that I can suggest is using Arduino BT over Bluetooth. Any more questions? Yep.
Okay, this is with respect to the last question. There's something known as PY formatter. So, though you can't upload code on the go or change code on the Arduino dynamically, you can load the formatter onto the Arduino, and if you're connected wirelessly, that you can change what functionality the Arduino has, and that's something I've been using.
Again, I did not get your question. Please repeat.
Okay, so like for example, if you say you are blinking a particular LED, and instead you want to do something else, so then you can use PY formatter for that.
Well, I'm not very sure as to how you would apply that, how you would implement that. Because in order to upload code to your Arduino,
you don't have to upload code. You don't have to upload code for that. If you had to upload code, that would kill the whole purpose of dynamically changing it on the go, because it would again have to reset and rewrite.
Okay. So if I get this correctly, are you trying to say that you want to implement, you want to do a particular thing on the Arduino, such as turn an LED on and turn an LED off from over the air or something of that sort, right?
Yeah, even the Internet of course, yeah.
Yeah. Well, of course you can do this, and there's something called as formatter, and there's something called as Python formatter as well. So formatter is a very simple library that will allow you to use your Arduino and do a very similar kind of thing. So there's a formatter library for both Arduino and for Python. So you can upload the formatter code onto your Arduino, and you can run the formatter code anywhere in the world on your Python computer or on the Python on your computer. And using formatter, you can definitely do that.
Yeah. So that's as close as you can come to changing code on the go.
Yes, it is not really changing code, but
but gives you the same functionality.
Yeah.
More or less.
Right.
Yeah. So, as you said that there is a set of libraries already available with Arduino. So, is it possible to extend these libraries if I want to write some of my own library? So, is it possible, and how to do that?
Well, definitely yes. The Arduino community survives like this.
Okay.
People like you and me are the ones who are actually writing these codes, examples, solving all the problems on the forums. So if you check up the libraries page on arduino.cc, that's the website of Arduino, you'll be able to very well figure out how to author libraries and what are the techniques that are usually followed for authoring libraries.
The other question is that, like you said, if you have to program something, there is a provided interface like loop and setup. So instead of that, if I want to program, means I don't want to use that interface, is it possible?
Well, yes, that is also possible. But I would beg to differ at this point. If you really want to do such a thing, you do not really need to invest in an Arduino board at all. You can simply take on a microcontroller, an Atmega 328, and program it using AVR GCC and an AVR programmer?
Because in the way there is some interface is provided, so definitely there must be some overhead. On the if I am going to implement some algorithms, there will be some overhead because of this interface.
Right.
So if I want to avoid that, and I want to at the same time I want to program it on Arduino. So
well, that is a wonderful point that is put forward by you. Of course, because of the interface, there is quite a lot of overhead. So if you go down to the C level of programming, the overhead is going to reduce quite a lot. And if you move down to the assembly level, well, that is almost equivalent to writing machine code.
yes.
So in that case, your program becomes a lot more efficient than your regular Arduino code.
Okay.
So yeah, if you want to move down further, you can definitely do that. And as for the Arduino board, you can actually write assembly code in the Arduino IDE, and that's going to work. But again, you will still have those overheads of using digital write or analog read.
Yes.
You will still have those overheads of doing those functions.
Thank you.
Quickly running you guys through the last piece of my code. Alright, so this is my Python code for reading serial data and sending across an email if the capacitive sensor is touched. Rushing you through the code, I simply import the time, the serial, the SMTP and the base64 library. I'm using the serial library, of course, to communicate with the Arduino, SMTP library to send out emails using the SMTP protocol, and base64 library just simply to encode my password in this case. And my receiving email address in this case is my personal email address, and my sending email address is some other email address, and here's the password. I've defined the subject and the text, the content of the email that should be there, and after that, moving on to the real deal, I simply create a serial object here, ser equal to serial.serial of that is the device name /dev/tty-acm0. So the Arduino shows up as this kind of a device, and this is how you connect to the Arduino or interface the Arduino using Python. And this particular statement is going to open your serial connection or is going to open your serial port. So if you do that, as Sudha put forward, that in that case your Arduino is going to soft reset. This is a simple function to send an email, and this is done using the SMTP library. So I create the SMTP server as the Gmail server, port 587. Just do a little bit of SMTP stuff and initialize, finally log in. After that, I'm setting all the headers for the email, and I'm printing the headers here. Finally, I compose my entire message, and in this statement, I'm sending out the email. Once that is done, I close the SMTP connection and the email is sent. Now this is where the code starts executing. I've put it in a try except block because what happens is when you open a serial connection and you do not close it, that is going to cause some trouble because we already have a lock on it, and if you're not closing it, that lock is going to remain there and you cannot really access it again without rebooting your computer. So I just print starting listener here, wait for a second, and then print waiting for movement. Inside this loop, I'm just waiting for message to come. I read the message over here, store it in the variable called as message. I print the message, and if the first character of the message is capital M, remember in that case it was movement detected. So if the first character is capital M, I simply call my function send email. quickly executing this code, when I start executing this code, it is now printing the value of the capacitive sensor onto the display. Now as soon as I touch the capacitive sensor over here, it reads movement, detects as the first character is M, and starts sending out the email. Once that is done, it carries on. Going back to the browser, I have an email here that says touch detected, and that says the sensor has detected a touch. So this is a very simple example of how you can interface a simple device as a capacitive sensor or any other sensor for that matter to the web and start sending across emails or start tweeting or start posting updates on Facebook using this. So that's about it, and I really hope that you guys go ahead and create some amazing things that are connected to the web. Thank you.
Thank you for the wonderful talk.